going? Hello, everyone. My name is Lauren, and welcome to the stream. This is Lauren Learns Things, and my name is Lauren. I am a developer educator at Vonage, and you're watching the stream in which I'm going to be learning things. Today, I'm joined by a friend and a colleague at Vonage. He is an iOS developer turned data science and machine learning enthusiast. And that's what we're going to be exploring today, because his mission is all about helping people understand what machine learning is and how we can use it in our applications. That's what we're going to be doing together. So let's intro him, and welcome to the stream, Tony Hung. There you are.
Hello.
Hello.
What's up?
What's up? I'm super excited to be working with you today. Can you tell me what we're going to be building?
Sure. So right now we have we're going to show you a Juniper notebook.
A Juniper notebook.
We're going to show you basically Python code,
Yep.
and we're going to build a spam detection model. So basically, if you have messages that are considered spam or not, you want something to predict it.
Yep.
So we're actually using this right now at Vonage as a proof of concept for all our messages. So we want to be able to stop messages that are spam, and make sure those don't go out. So we're going to just build a simple model that shows you how to basically get a data set, which is just a CSV full of text is labeled spam or also not spam, also called spam. So we'll do that. We'll build a model, and then we'll deploy it to AWS Lambda. At least we'll show you how to deploy on Lambda. So you can have an endpoint, and from there you can have a bunch of messages sent through, and you can do your own predictions.
Cool. And so in theory, the use case is if a company is sending messages, they want to detect the spam, or is it someone receiving the messages that wants to detect the spam?
It would be someone sending a message. So even for
Cool.
Vonage, so Vonage has a bunch of services for sending SMS. So this is what we're using it for. So this is something that's it's not just a toy project.
So
we're using this.
I'm pretty used to building small demo things that are apps for, I don't know, just a quick demo of how to use one of our APIs that maybe lives locally, or I'll deploy it to Heroku. But this is really cool because it's something that is what the company uses. And I should say that, Tony is a software engineer at the company. And so, he's working on all you're working on all of this stuff in live production. So very cool. So what you've sent me and what we're going to be looking at right here is all of this is a Juniper notebook within Google Colab. And those two words I'd never said before in a sentence before this week when we started prepping for the stream. So I'm pretty excited about that and what playing with it today. Do you kind of want to give a rundown of what this is in general?
Sure. So Juniper Notebook is basically a notebook that you can write text in, you can do math formulas in, and you can write Python code. And it's all visual. It's mostly for data science, machine learning engineers to do prototyping on models, get visualizations, charts, things like that. And there's a lot more work on actually getting these things to production. So you can say export this out into a blog post. So there's a bunch of people that are doing something where you take a notebook and you can export it as a markdown, and you can have your blog from there. I've seen people use it for GitHub repos. If you want to have a GitHub website to show a blog, you can do it through these notebooks. But these notebooks basically let you run code in Python, and you can install libraries if you need to via using pip. Pip is an installer library. You can download all these frameworks to use. And Google Colab, do it all for free. And you don't have to have it local.
That's where we are in it right now. Okay. And it's shareable too, right? You toss this to me, and then in theory, I'm not going to run yours. I'm going to make a copy of mine, or copy so that I own it then. Okay. So let's all do that right now. And opening that up.
Okay. Hold on, my dog needs to come out.
Well, no worries, because it seems like my Wi-Fi is really slow because that took a while to open. So fingers crossed, everybody. All right, so today we're building, as you said, that machine learning model to predict if a SMS is spam or not. And so what is this? Will we use the scikit-learn library? What's that one?
Yes. So scikit-learn is a machine learning library that lets you have a bunch of machine learning models to make predictions on. And these models they're very simple. There's things called like Gaussian native Bayes. You can do SVNs. I mean, we're not going to go into detail on those. That's a whole like another year of research if you want to learn how models are produced. But that's a big
awesome
thing too.
To know.
Yeah, it's maybe not a year, maybe like a couple. Yeah, so scikit-learn lets you do these things really easily. So, and later on, we'll show you how to do it. And as a software engineer, you don't need to like understand, like you don't need to know how they work at first. You can just run them, see what they do, and then tweak them. There's parameters you can change. And the model we're going to show you is really simple. It's literally like lines of code, and it'll give you a number. That number is going to be how well it did on the data set.
If I wanted to share this with the chat, can I just share this link so that people can follow along with us?
Yes, you can go into the share thing on the top right, and then it should just be it's as if you're sharing as a Google Doc. Same idea. You can allow people editing or give them full access.
All right, so I popped that into the channel or chat. And okay, so do we with Google Colab, you kind of run them in steps in orders of operation, and so the first one at the top is the one we begin with. Is that right? Okay.
Yes. Yep. You can run them sequentially. You can run them out of order.
Yeah. Okay. Cool.
For now, we'll just do it like you can. Yeah. Think of it as like global variables that you have. So if you run something somewhere, you can do it later in the cell, or if that variable still exists, it'll run.
Got it. So interesting. I'm looking at your note here. You said that we will, you're going to be calling something either spam or not spam, aka ham, which is really funny. And I'm not sure if you admit, but and then our model is trained. We'll deploy it to AWS.
Yeah,
it's great.
I don't know why they call
really
it
funny.
that.
And then we need the data, so you have that CSV set right here, also linked. And so cool. Okay. So that has 5,000 messages that are labeled. Okay, interesting, neat. So to start, do I just like hit the play button, or shift enter? What's like the shift?
The easier way is saying shift enter, but when you click on that play button, it's the same thing.
Okay.
It'll run the cell. So when you run that first cell, it's gonna execute that code. So that's not Python. That's actually Bash. So the exclamation point in front lets you run Bash. So we're just using the wget library in Bash to just download that data set.
Okay.
And then we're going to unzip it.
So it said...
So that's another cool thing about Juniper Notebooks. You can run Bash scripts.
So we saved it, and then we like have inflated it. And so then it says once we downloaded the data set, we'll load it into the pandas data frame and view the first 10. What's the pandas data frame?
So pandas is another machine learning library that's used. It's really good for manipulating. Yeah, it's another library. It's not just for machine learning. A lot of people in Python use it for manipulating tables, doing functions. Like you need to say you have two columns. You need to multiply them. You can use pandas really easily. So instead of like looping through each one, there's a function in Panda to say, do this whole thing in all of the rows, and it'll do it for you much quicker than looping. But there's plenty of other reasons pandas. We could have just used a regular CSV library in basic Python to just load the library. But Panda is just easy. So this function called read CSV. In the first parameter is the path to it. So SMS spam collection is what we just downloaded. Separator, that's for the data set that gets downloaded. It's it's tab delimited, so we do that. Headers, like as the first row is a header, we say no, and names are the columns. So if you look at the output of that, there's label and message, and that's what the CSV that we just downloaded. So the first column is all the labels. So the data set has all these messages, and they're already labeled by somebody. So someone went there and it says, "Is this spam or is this ham?" So look at this one. This looks, like somebody's talking to somebody. That's
cool. So
number 2, comp.
Okay, should I run
so
it?
These
then?
are already labeled.
Okay, all right.
Yeah, go for it.
Oh, it looks like I got the same.
Yeah, it'll give you the same first
cool.
rows.
It didn't look like it looked any different than what it was before.
Oh, yeah.
Okay. Okay, so then we have to understand the data before building a model. Yeah, that's a good idea. Okay, sorry, it's stupid.
Yeah, so like you can't say I'm gonna do something.
Okay.
You need to like look at it first and just trying to get like understand what this
so
data
you need
is.
to see how many messages are considered spam or ham before you look at it. So, okay.
Yeah. So that df.label.value counts is another pandas function. That's saying give me all of the labeled the examples of what the label is. So you'll see there's 4,825 messages that are considered ham, and then the rest are spam. So it's very it's not very even, which is fine. Which is what we expect in like in the real world. We would expect more regular messages than spam. So that's fine. But this is just a good quick way to see what do we have here? What are we dealing with? And the next two cells, we just kind of go into a little more detail. Like, let's just look at a couple. So where I'm doing, so df label equals spam. That's just like a little. It's like a filter.
Okay.
That's all I'm doing.
Yeah, just pulling out the few spams.
The other ones.
Okay.
So we're saying
you need
df
permission
label
to access that doc. It's not public.
Yeah. So we're just saying.
Let me make sure that this. Oh, it's here it says anyone at Vonage can view the link. So maybe I need to figure out a way to make the link outside of Vonage viewable.
Yeah, so
good looking out.
Go to share. Go to where is it?
Maybe just.
So I just did it before too.
Only specific. No. I mean, how do I not know? Oh, yeah. Go to anyone with the link.
The bottom.
Maybe.
Yeah, it should say anyone on the internet.
Oh, anyone. Anyone. Yeah. Let's go anyone with a link. Let's keep some proprietary. I mean, wait, that's probably not the right word. Properness.
Sure.
Okay, whatever. Okay, so that's the updated one. That we've. Let me get updated link.
That should be good.
Thanks, Aaron, for checking that out.
Yeah.
Okay, cool. So we were just looking at the example of some of what the spam messages look like. Free entry. Yeah, I mean, those definitely look spammy. So, okay. So just inspecting that a little bit and then running it to see.
Yeah.
I have a question. It seems like everything already ran, like all of the info is already down below the cell. Does that happen? Like, if you press Shift Enter?
Okay. Well, if you've already run it before and you've saved it, it will save the output for you. So if you've already run this before, so when I make a change and I do the output, and if I save it, you'll see the output as well. There's ways to say don't show the output.
Okay, cool.
But
no, that's all right. That's okay. That's still it's interesting to learn that. Okay, so then after looking at some of the messages, we can see the spam messages look spammy. Yes, I would agree with that. Okay, so we're now at the pre-processing phase. Oh gosh, what am I looking at here? This seems. I'm nervous.
It's a little bit of math, but
talk me through this.
I'm nervous trying to go into detail on this. Okay. So basically what we need to do is we need to convert all these texts into numbers. So that's all what machine learning models can do. They can only read numbers. And we can do a couple things that are kind of trivial. Like we can convert every string in the text to a number and then make a prediction on that. It's gonna be pretty crappy because it doesn't know where the similarities are. So there's this thing called term frequency inverse document frequency. It's a lot of words, but all that really is that we, for each text that we take, every word in every documents think of as each message. For each message and every single word, compute how many times did it show up in the list. So I tried to find some screenshots to show you what it is, and there's more there's better posts that go into it in way more detail than I do. So if you look at the bottom table, which is document 1, document 2, term 1, term 2. For our example, think of document 1 as the first message. And document 2 is the second message.
Okay.
Term 1 is a word.
Term 1 is a word.
Yeah. So each word, and then there's a percentage there. It's basically it's a float.
Okay.
And it will be able to. So what the formula is as on the top. The number of times, say the word "the" is in the document, divided by all the terms in that one document, times all the documents divided by the number of documents that contain that word "the."
No. I think I'm still with you, oddly.
So, what's cool?
I'm here. I'm there. Okay.
Oh.
So.
I've also included a source.
The notebook. Okay.
In there, and a nice.
Cool. Well, that's awesome notebook for readers to have a reference.
Yeah. So that one I found. Yeah. So that notebook shows you how to write it in pure Python. So we don't have to worry about that because scikit-learn does it for us. So, but it's nice to know, understand the math of it. Again, you don't have to. It's nice to know. Really should. But that's what that does. And if you do scroll down to, there's a when I say after we fit the TF ID vectorizer, you'll see the actual matrix.
Oh, wow. Look at that.
So on the left, you see backward, bad. So if you look at the word bad, so on the left, every row, it's every single word in our data set from the spam or hem, doesn't matter. It's every single word. So right now we've only done 5 rows because it's massive. It's a massive file. What is it? It's 4,457 by 7,741. That's a massive matrix, and we're obviously can't show that in one screen. So I just tried to find one that looked reasonable. So the word bad, it occurs in document 3, and it has a value of 0.193. So that if you put in that formula, it'll give you that number, and it's basically it's almost like a ratio of every word to every document.
Okay.
And that's how the model is going to be able to.
Okay.
Yeah. So spammy words have like winner, let's say.
Yeah.
That number will be a little bit higher. So the model is able to say, okay, this number is higher. So anytime I see a message with the word winner, I'm going to try, or at least think it could be, I'm going to think it's going to be a message of a spam. And that's really it.
Yeah.
Think of it as a ratio.
Totally makes
every single
Jupyter Notebooks rock. Totally agree. Okay. And if anyone in the chat is having questions about this also, feel free to chime in, because maybe this makes sense to everyone else. And this is my first exposure to whatever we call TFIDF. Okay. I'll never forget that. TFIDF. Don't you know? I'm going to talk about it at the dinner table tonight. TFIDF. Okay, got it. I've learned it. It's in my head. So I'm gonna run the first one, and it's doing that, what we just showed, that like that mathematic.
So the first one
equation. Right.
Yeah. So. The first cell, there's a function I'm calling called train test split. That's actually just splitting our data set. So the next cell will be
TF-IDF vectorizer. Oh, that's even better of a word. Okay, TF-IDF vectorizer.
That's.
Whoa. Okay. Yeah. Wait. So there's our matrix. The sparse. Okay. So, this is making sense. Okay. So.
A sparse matrix, a massive matrix with a whole bunch of zeros, mostly zeros, with a little bit of values in between. And that's why at the bottom you see I'm the backdoor. Those are all mostly zeros, because is backdoor going to be in every single document? What's the chance of that word being in every single document? Not very much. And we have 4,500
columns. So you're just plotting a few of the rows.
It could be there, maybe not.
Okay.
So that's what the sparse matrix
is.
Yeah, I just tried to find something that had some data.
So then we'll take the training and the test data set, and we'll use the TF-ID vectorizer. Vectorizer. I can't. Okay.
Yeah. So we're going to do. Yeah. So we're going to take just the training examples. So machine learning, you basically have a data set there are our spam and ham data set. We're going to split them. Basically, we're going to take 80% of those messages.
Okay.
We're going to train our model on those. And then when we're done with it, we're going to see how well it did. So we're going to take the test set. So again, it's 20% of it's basically the rest of the data set. So we'll make our predictions on those. And that'll let us know how well we did. On that's basically it's called accuracies. How well the model did. How well can it understand that a message is spam. So we're
teaching our little robot.
So that's what that does.
And we're teaching it what spam looks like. We're like, here, little one, this is spammy, this isn't spammy. But I have a question about Google Colab. Because it doesn't, not always does the code, because we're not printing anything out to the console or anything. So it just, what if I had forgotten to run one above, you know what I mean? What if I didn't run number 7 of the code snippets and is it okay? Will I somehow notify or get an error log of some sort that if I didn't do it in the correct order or something like that? Okay.
Yeah, you'll get an error. Okay. You'll get a Python error if there's something not defined. You'll say, "Oh crap, this is not defined."
So I think I just ran the 10. I ran it twice accidentally, but I think that's okay. Oh, and look, there's some notification. If you hover over it, it says this was executed by you. Oh, that's handy. Jeez, Google Colab.
Yeah.
Okay. Anyway, let's get to training the model. Wait, right? That's where we're using the Gaussian naive Bayes.
Oh no.
Are we gonna?
Yeah. So that convert to features function, that's just taking all that data, and I'm still a little unsure of what the transform does. Basically, there's a vectorizer which we need to train on the data set, and then let me go to that cell too. Basically, all of the training and test set, we're making another sparse matrix of each of those, and X-train features and X-test features are basically 2 sparse matrices that we'll be using for our model. Just think of it like that. Just think of those as just a matrix of numbers, floats, technically. And
I'm with you.
So the model training one, that's where we actually train the model. So scikit-learn, there's a function called Gaussian naive Bayes. It's again, there's a bunch of YouTube stuff to show you what naive Bayes function is. It's a probability function. I can probably go into more detail. I gotta figure it out. So I still get confused.
It's good to know that it's just something that we can use as a model. It's a good starting algorithm for text classification. Nice. So it's our entry level text classification model. Okay.
It's really it's good for this stuff.
Yep. I can hang. Yep. Right.
So
cool. So now it's time to
in that
model it, right?
Yeah. So those 3 functions. I'm sorry, not functions. The 3 rows. So Gaussian naive Bayes, we initialize it.
So
there's a function called fit, and the first parameter is the training set, and basically there's X train and Y train. So X train is the training data set of all the messages by the TF-ID vectorizer. The Y train is vector, which is basically a single column of messages that are spam or ham. So it's just so you can't see it on there, but it's going to be either the word spam or the word ham, and we'll convert that to a 1 or 0. Just because again, the model can't do text, so everything that's classified as ham will be 0. Everything the word ham will be 0, and the word spam will be 1. And that's how we fit. So the fit function takes that training data. Takes the training stuff, takes the Y, and then computes. And then that will take
I got it. So we got that accuracy.
It's pretty quick on this data set.
0.898. So that's good, right? That's close to 1 ish. Right? That's pretty good.
That's pretty good, yeah.
About it. I mean, okay. But then once you have that, you're then what's this next piece? You take the pd.data frame.
So Yeah, so this I'm showing, so you need to
Oh, yeah.
run that one. So what that's going to show you, it's going to show you how well the model
Oh.
did. And it will show you as a, what's the word?
Spam.
So you see that, you'll see a table with true positives, and it's called a confusion matrix.
Okay.
That's a word, yeah. So it's a confusion matrix, and it shows you how well it did. So in the first column, there's 806 messages that were thought as spam and that were spam. I mean, sorry, ham. And you look at 102, that means the model. So the value was ham, but the model thought it was spam, so it's wrong. So you want to look at it as diagonal, as the true ones that the model did get
spam,
correct.
Spam.
So for ham.
Okay, got it. Okay, that makes a lot of sense. So I see your explanation there is good. So we've classified as ham. We're actually 866 were classified as ham. We're actually ham, but 136 were predicted, but they okay. Were predicted as spam. We're in fact
we're actually spam. That's good.
Good. So we
the
don't like the 11.
It didn't get it right.
Yeah, 11 and 102 were your flops, if you will.
Yeah.
Okay.
Yep.
Okay.
So, yeah, so it looked like there actually were 102 messages were ham, but they were classified as spam. So that's not great. But, for a quick little test, so what we can do, we haven't done a lot of things to change the text and, clean it up.
Yeah.
We haven't done any of that.
Oh, so you can do that. You can.
If we clean it up,
is it an iterative thing that you can always be changing, updating?
Yeah. Yeah, so we could do okay, this is great. Let me see if I can remove words that aren't really useful. So words like the, and, is, then, they don't, if you have a message with the word is, you really don't know if that's spam or ham. So let's just get rid of them.
Yeah.
That's one way to do it. That'll clean up our TF-ID vectorizer. So we'll get rid of words you don't need. There's things where we can make sure everything is lowercase, because words that are capital and lowercase will be basically two words that can confuse them on a little more. So, but again, this is more like trial and error. It's really like a science.
You have to be open to the experimentation.
Nothing ever works perfect.
Yeah, that's interesting. I think it's a different shift of mindset, where from a programming perspective, I have this it either runs or it doesn't. Like it passes all the tests or it doesn't. But this is interesting where it's like, okay, you're okay with some failure moments because you're just going to continue iterating on it. And so that makes sense that this is like the evolution of it is a part of the process. So that's pretty cool, actually. Okay. So.
Yeah. But the problem is that if something's broken, you have no clue why. Like, where the hell is it going? And you're crazy.
Right.
Like, what am I doing wrong?
How is it learning?
You can't just you could Stack Overflow it, but.
Do you just get better with time, or is it do you learn the tricks of the
we have little music that says under maintenance or something like that.
I could hit it to standby. Oh, it's back? Sick. All right. Hello, everyone. Sorry about our problems technically. My neighborhood is hot with a lot of people working from home during this time, and our Wi-Fi is pretty slow. So I'm hoping we will be able to stay online for the remainder of this tutorial. Tony was just walking me through, kind of helping me understand, as he said, it's hard to debug sometimes to understand where your model is erroring out or why it's not working in some sort of way. So I was kind of asking, is it with time that you get better at it, or how do you find those areas of confusion and identify it? I thought that was could be kind of interesting to understand. Sure.
So it's mostly trial and error, really. So you'll try something out, it doesn't look good. A lot of posts that I read to see what other people do with this data set, and it all depends on the data set too. If everyone's using this data set, you can probably see what other people did and get better results.
Okay.
But if it's our own data set, so for Vonage's example, we have our own messages.
Yeah.
So we can't use this data set for training because it's not our messages. Right. So we have a whole bunch of messages that we'll get, and we can see how well it does on our stuff. And if it's if we get different accuracy, we may need to do a little more. We may need to change the models. So when I was first doing this for actual production, I have a notebook that goes to every single model. It does a bunch of hyperparameter testing. So each function in scikit-learn has a bunch of hyperparameters. They're basically just parameters. Think of it like,
Okay.
I don't understand them all, but you can do like sweeps of them. So, hey, try this number, try this number, try this number. And then after all that, they'll say, hey, this one's the best. And say, okay, great.
Interesting. That's cool. That's cool. And so then, well, like, I'm curious even to know, and we'll get back to the browser, we'll get back to working our way through that in just a second. But I'm curious even to understand, like, what, for you, what was your path and entryway into all of this and like learning about machine learning and whatnot? Hi, Diana. Welcome to the stream.
It was kind of random, really, where I just went to an AWS talk in New York, and they were talking about using Amazon SageMaker, which is their machine learning pipeline where you can have notebooks and do all that kind of stuff and run models. I'm like, oh, this is pretty cool. So I just did a lot of research. I've been taking some courses. There's a Coursera course I did, which was very math focused. Tried to do a Stanford course. I couldn't get it because it was all math.
Yeah.
But then there's a course called Fast.ai. It's actually being hosted now. So it's a guy in University of California, basically. So he has his own course. It's free on YouTube. He does it maybe every 6 months or so. And that's a great way for anybody to get involved. And it's really geared towards software engineers, but you don't have to even know Python to understand it. He goes through, there's a method that he's using. It's a top-down approach. So think of it as if you're a kid learning to play soccer, they don't tell you what the ball is and what the circumference of the ball is and what's it made of. They say, go play and see what you do. This is the same idea.
Yeah.
So they say, let's build an image classifier, and we'll build it. And then it's great. It runs. Okay, then how is it built? And then we'll slowly
peel it
back into it. It's a great course.
Cool.
Like if anyone wants to check it out, I say, go for it. There's a bunch of forums on the Fast.ai course.
Okay. Yeah, Noreen linked it in the chat. Thank you, Noreen, so much for that. Oh, that's fun. Look at your chat that's great. Thank you so much for being annoying, chat. Okay, cool. So let's then dive us back into
all right.
Let's go there and have a further discussion on where we left off, which was at the inference phase of things. So where are we now with I guess like we've trained it a bit, or we've tested the training, but now we need to step further into it. What is this phase?
Well, we're basically done with the model training, so we just want to see how well it did.
Oh,
so
cool.
That's all this is doing.
Okay.
Inference is basically saying, give it some examples and see what it predicts.
Okay.
That's same thing as inference. It's inference, predictions, testing almost. It's all interchanged. So the first one, where
I see.
you say, I'm on my way home.
I'm on my way. That's not spam.
And
that's ham.
That's right. And you could change it yourself if you want. You can go in there and you can change it. You can say hello, hi, whatever, and run that cell, and it'll give you the prediction.
Hello. So I am not spam. Is it spam or is it ham? It's spam because I said spam. I mean, that's probably fair. Hello, I am not. Hello, I am excited about ML. Okay, and then, all right. And then it's ham. Yeah, that seems cool. Okay, cool. And so here, I agree, Noreen, it's super cool. Okay, so this one, because it looked like in the CSV file, like a lot of the spam things were like free. This is like your opportunity. And so this one doesn't say that really explicitly, but like it's TF-IDF vectorizer, and we'll use this when classifying incoming message. So then we'll use it later. So we have to essentially export the PKL. What's a PKL?
Can you hear me?
Yeah, I can hear you. We have to essentially